We interact with these incredibly powerful AI models just about every day now. But how do we actually know they're safe? How do we stop them from causing real-world harm, whether it's by accident or by design? Well, that's where we dive into the fascinating world of AI safety, and more specifically, the ethical hackers who are hired to break these systems for the good of all of us.
Right? That is the multi-billion-dollar question, isn't it? When you have an AI that can write poetry, that can code, that can hold a conversation, its potential for harm is just as complex. So finding these vulnerabilities before they get exploited is, without a doubt, one of the biggest challenges in artificial intelligence today.
And the stakes just couldn't be higher. This quote from a really foundational paper by Anthropic back in 2022, it just perfectly sets the stage. As these models get smarter and more woven into our daily lives, the need to proactively find and fix their flaws becomes absolutely critical.
So, to understand how we can protect these systems, we first have to figure out what we're protecting them from. I want you to think of it like we're planning an ethical heist. Before you can even test the security, you gotta know what treasures, or in this case, what dangers, are locked away inside that vault.
And the list of potential harms is, well, it's vast. An unguarded language model can end up amplifying all sorts of societal biases. It can produce really toxic hate speech. It can become a tool for mass disinformation. It can accidentally leak private data from its training set, or it could even give instructions for unethical and dangerous activities.
So how do you find these flaws? Well, you hire a crew of ethical hackers. And this is the core idea of what we call red teaming. You basically create an adversarial team, and their only job is to attack the system, to push its boundaries, and to trick it into failing. All so the engineers can go back and build better defenses. Anthropic did exactly this. They assembled a specialized crew for this mission. And their goal wasn't just to kind of poke at the AI here and there. Nope. It was to launch a systematic, large-scale assault on its safety features to see exactly where and how it would break.
Now, what's so interesting about this slide is that it shows the actual mission brief. There was zero ambiguity here. Their mission was crystal clear. Go break the rules. The researchers told them, and you could see it right there, your goal is to make the AI behave badly, to get it to say obnoxious, offensive, and harmful things. They were explicitly told to provoke the AI into saying the very things it was designed not to say.
And this was not a small operation. The Red Team was made up of 324 crowd workers, a really diverse group hired specifically for their creativity in trying to find the model's weak spots.
In this slide, this is so cool. It gives us a look at what that process was actually like. On the screen is the interface they used. The red teamers would have these open-ended chats with the AI, trying all sorts of different tactics to trick it. Now, after each prompt, the AI would generate two possible responses. The red teamer's job, as you can see from that rating scale at the bottom, was to pick the more harmful of the two, essentially guiding the AI down a darker path so they could map out all its vulnerabilities.
Okay, so this wasn't just one heist. It was more like a series of heists on different vaults, and each one had its own unique security system. The real goal was to see which defenses could actually withstand the most sophisticated attacks.
The team tested 4 main types of models. Over on the left, you've got the simple defenses, a plain, off-the-shelf language model, and then one that was just given a simple prompt to be helpful and harmless. On the right, you have the advanced defenses, one that would generate a bunch of responses and then pick the safest one, and then the most advanced system, which was trained using something called reinforcement learning from human feedback, or RLHF. That's a fancy way of saying the AI is fine-tuned based on humans ranking its responses.
The scale of this stress test was just massive. Over the entire course of the experiment, the Red Team launched nearly 39,000 unique attacks across all the different models and sizes. This wasn't just a test. It was a siege. So, after this completely unprecedented stress test, what did the team find? I mean, which security systems held up, and which ones just crumbled under all that pressure? The results were, well, they were a little bit of what you'd expect, and in one key way, completely surprising. So the crucial point is right here on this chart. This is the big reveal. For most of the models, making them bigger and smarter did not make them safer. But for the RLHF models, something amazing happened. As the model got bigger, we're talking from 2.7 billion to 52 billion parameters, which you can kind of think of as the knobs that determine the model's knowledge, the success rate of the attacks went down. The bigger and smarter it got, the harder it was to break. This was huge. For the first time, safety was scaling with capability. And this quote from the paper really drives the point home.
It was a landmark discovery. For the first time ever, researchers had found a method, RLHF, that didn't just sort of patch safety on top, but seemed to bake it right into the model's core behavior in a way that actually got better as the model itself improved.
So what kind of attacks were they trying? Well, this visualization maps out thousands of them. Every single dot is an attempt to break the model. You can see these clusters of different harms, everything from offensive jokes and racist language all the way over to soliciting advice on theft, violence, and other really harmful activities. It's just a vivid landscape of the AI's potential for misuse.
So this ethical heist, it was so much more than just a successful experiment. The findings created a ripple effect across the entire industry, and it really established a new blueprint for how to build and test for AI safety.
The legacy of this one paper is just immense. First, it proved that RLHF was a scalable way to improve AI safety. Second, it helped standardize red teaming as an absolutely essential practice. And third, by releasing their entire data set of almost 40,000 attacks, they gave the whole research community a powerful new tool to build even better defenses.
And this is why this all matters to you. The safety features that are in the AI tools you use today, those guardrails that stop them from generating dangerous content, they're the direct descendants of the techniques that were proven in this very paper. It really did lay the foundation for the safer, more aligned AI systems we have right now.
But of course, the work is never really done. As AI gets more powerful, new, more subtle vulnerabilities are going to emerge. The blueprints for safety are clearer than they've ever been, but that race between the builders and the breakers, it continues. Which leaves us with the crucial question, what hidden flaws will the next generation of ethical hackers discover?
This is for entertainment purposes only.